All right, welcome back. I asked you to try and figure out f of 4 and f inverse at 6. So remember, f of 4 means that the x value in the function has been replaced with 4. So in this particular case, f of 4 is equal to 2 times 4 minus 5 over 3 times 4 plus 7. So 2 times 4 is 8, minus 5 is 3. 3 times 4 is 12, plus 7 is 19. So f of 4 is equal to 3 over 19. Okay, as for b, f inverse of 6, there's two approaches to this. You can either find the inverse, because what this is asking for is that is telling you the x value on the inverse is 6. Okay, but remember, one of the things we learned about inverse is that the x value on the inverse is the same as is equivalent to the y value on the original function. So this is the exact same thing as solving the equation f of x equals 6. So let's do that. That's much easier because then we don't have to find the inverse. So that means we're going to set the y value equal to 6, and we have 2x minus 5 over 3x plus 7. And we're left with some algebra here to try and solve for x, but it's still very, very doable. So just like before, we're trying to solve for x. Let's get it out of the denominator. So we're going to have 6 times 3x plus 7 equals 2x minus 5. And once we've got it down to here, it becomes a lot simpler, right? This becomes a lot like a grade 9 type of equation you've been asked to solve. So we multiply through. Okay, and then it's just a matter of collecting your like terms. So you end up with bring the 2x over, 16x over here, and 47 on the right-hand side of the equation. So x is equal to 47 over 16. Okay, so that's the solution to f inverse of 6. Okay, and last but not least, ask you for the domain and range of f of x. Now again, this one's not based on any kind of parent function, so we can't use that, like there's no mapping rule here trying to determine your new domain and range. What we're left to do is try and figure it out just based on what we know about domain. So one thing to remember, at least for the domain, is that you know that you cannot have an x in the cannot have a 0 in the denominator of a function. So if you're looking at this function here, we have f of x equals 2x minus 5 over 3x plus 7. We know that that denominator here, 3x plus 7, cannot be equal to 0. So what value of x makes that 0? Well, if we do some quick little algebra here, we wind up with x being equal to negative 7 over 3. Okay, and what that is telling me is that when x is equal to negative 7 over 3, again, it means the denominator is 0, so my domain is that x cannot be equal to negative 7 over 3. So that's one part done. But what about the range? We have no way of actually telling what the range of this function is unless we graph it, and we need another way of figuring that out. So one thing that might help you remember, or one thing that might help you figure this out, is that knowing that the range of a relation or a function is equivalent to the domain of its inverse. So if we could find out the inverse of this function and try and find the domain of that, that would actually help us find the range of what we started with. So let's actually see if we can figure out the inverse of this function. Okay, so remember, there's more than one instance of x here, so we can't use input-output. So for the inverse, we have to interchange x and y. So we're going to have x equals 2y minus 5 over 3y plus 7. Okay, so let's try and, I want you to try and find the inverse of this on your own. Try and work through the algebra, see if you can get it to work out, and push play and go through it together. Okay, so hopefully if you check your answer, you got the same inverse as me. So reminder, I interchange x and y, and I'm trying to solve for y. So I multiplied both sides by the denominator here, 3y plus 7, and then use distributive property, just to expand and simplify the left side. So again, my goal here is to get all my y terms together so I can isolate. So that means I collected the 3xy and the 2y together by subtracting the 2y over, moving it to the left, then move the 7x over to the right side. And then from here, again, the only way I can isolate for y here is if I factor out as a common factor y from these two terms right here. So I factor out the y, and I'm left with 3x minus 2 left over, which when I divide by 3x minus 2 gives me negative 7x minus 5 all over 3x minus 2. So that is now the equation of my inverse. So remember, the reason we were doing this was we didn't know the range of our original function. But if we can find out the domain of our inverse, that will give us the range of our original function. So for the inverse, if I look at the domain here, okay, I can't have a denominator of 0. So a quick solving for x here tells me that an x of 2 over 3 would make that happen. So my domain of my inverse is that x cannot be equal to 2 over 3. Okay, so what that tells me, going back to really what I was looking for in the first place in my original function, is that the range of my original function should, instead of x, we have y, and y cannot be equal to 2 over 3. Okay, so if you're ever stuck and you can't find the domain and range of a function, but it is possible to find the domain and range of the inverse, you can use that to help you get what you need. Okay, so now with that in mind, here are 4 functions. I want you to tell me the domain and range of the inverse of f. So I'll do the first one with you, and then I'll leave you try the rest on your own. So for the first one here, what I find easier is to start with my original, and then think about what's happening with my inverse. So I have the original here, so I know the domain of the original, that's listing all my x values here, will be in order negative 4, negative 3, 6, and 11. Right? Negative 4, negative 3, 6, and 11. My range, all my possible y values, will simply be negative 7. Although, so if I'm going in order here, negative 9 would be first, then negative 7, and then 8. Okay, now, remembering that for the domain and range of my original let me repeat. The domain of my original will be the range of my inverse and vice versa. So if I want the range of my inverse, I can use the domain of my original. So the range of my inverse will be that y is equal to negative 4, negative 3, 6, 11. And the domain of my inverse will be that x is equal to negative 9, negative 7, and 8. And I could take the inverse here and determine all that information for myself, but if I can figure out the original, I don't need to find the inverse itself, because, again, I have my original domain and range. I can find the domain and range of my inverse. Okay, with that in mind, I'd like you to try B, C, and D on your own, and once you've taken a few minutes to give that a try, push play, and we'll go through them together. Alright, so let's run through these together here. So for B, we have a mapping diagram, which tells us that you have x values of negative 5, 12, and 37. So I'm going to list those as my domain, and I have y values, possible y values of, in order from smallest to largest, negative 3, negative 1, 8, and 19. So I'll list those for my range. For the inverse, the domain and range will interchange. So for my inverse, the y values from the original range become the x values for the domain of my inverse. So x is equal to negative 3, negative 1, 8, and 19. And for my range of my inverse, I look at the domain of the original. So I have y equals, forgot that there, y equals negative 5, 12, and 37. Okay, C takes a little bit longer to do because it takes some work to get the original domain and range. So this is what we did last lesson. So a bit of a test of whether or not you did your homework or not. So this is a transformation of y equals root x, which has an original domain and range of x is greater than or equal to 0 and y is greater than or equal to 0, respectively. So if I create my mapping rule to go from root x to f of x right here, I get x minus 9 over negative 7 and 2y plus 5. So I throw my 0 in for x into the mapping rule. So 0 minus 9 is negative 9 divided by negative 7 is positive 9 over 7, but division by the negative here changes the direction of my sign from greater than or equal to less than or equal to. Okay, so for my range, I put in my 0 into the mapping rule for y. 2 times 0 plus 5 gives me 5. No reflection there, so y is going to equal to 5. So for my inverse, my range of my original becomes the domain of my inverse, so I get x is greater than or equal to 5, and my domain of my original becomes the range of my inverse, so I get y is less than or equal to positive 9 over 7. And last but not least for D, I'm not giving you the function, I'm actually going straight to giving you the domain and range of the original function. So just to go straight to the domain and range of the inverse should be a simple matter of interchanging them. Domain of my function becomes the range of my inverse, and the range of my function becomes the domain of my inverse. Okay, so last but not least, last thing we'll do in this unit is I'm going to give you a function here, and I just want you to solve two different equations, one where g of x equals 13, and one where g inverse of x equals negative 9. Yeah, I'd like you to try them on your own first, and just see if you can work through the algebra, and push play to check your answers and go through them. Okay, so take a minute there and check your answers for both A and B. Now with A, remember that when it says g of x equals 13, that really means y equals 13, and when you're trying to solve for the x value, that makes that true. So I set y equal to 13 and went through a little bit of algebra here to solve. Subtracted 1 from both sides of the equation first to get 12, then multiplied by 2 to get rid of that denominator of 2 there, divided by 3 to isolate the square root there, and then I squared both sides to get rid of the square root. So there I squared that. That left me with 64 equals 4 minus 5x, which I finished solving to get x equals negative 12. As for part B, when it says g inverse of x equals negative 9, remember this is actually saying that the y value on the inverse is negative 9. Well, if it's the y value on the inverse, that means it's the x value on the original function. So this is the exact same thing as putting in x equals negative 9 into the original function. So when saying g inverse of x equals negative 9, I might as well just say g of negative 9. So I sub negative 9 into the function for x, and then simplify as best as I possibly can. So I wind up with, after some quick little math here, root square root of 49, which becomes 7. And then after some simplification further, I get 23 over 2. Okay, so that's it for this one. That's it for the unit. So the inverse worksheet I gave you earlier on, the unit now has you're now able to do all the examples that are on there. So give that a try, and then you can start getting ready for the test. Okay, that's it. That's all.